Hi, folks, and welcome to the CARC Emerging Centers call for May. We'll have a talk from Christina Koch and Tim Cartwright on Open Science Grid and offerings that are pertinent to emerging centers. Before I hand over the podium, so to speak, we'll do a quick overview for folks who may be just joining us for the first time. CARC is the Campus Research Computing Consortium, and works to extend the effectiveness of the research, computing, and data community for researchers, for professionals, and overall accelerates the ability of our sector to deliver services and resources for researchers. You're in the Emerging Centers call right now, and that's part of the People Network tracks. There are 4 other tracks that you can take advantage of. This call is actually a bit of an extension or collaboration with the researcher-facing track, where our guests were featured in March, I believe. But the People Network is essentially sort of an ongoing conference with monthly calls on various topics pertinent to those tracks. You can join and dip into any of the ones that you like or that pique your interest and move in between. There's also a set of interest groups that cover particular topics, including workforce development, challenges with research, data security, cyber infrastructure in the EPSCoR states. And then we have a set of working groups that are producing documents and policies around where we think the overall sector should be going. CARC is a volunteer organization. Largely, if you want to, say, join our steering committee for emerging centers and provide input on how you think these calls should run, you can get in contact with myself, Rich Knepper at Cornell University, or Patrick Clemens, who's the other chair of our track. And if you have any questions, feel free to either put them in the call document, which I've posted a couple times in chat, and I'll keep posting that throughout the call, as well as just sort of signing in when our guests indicate that they're available for questions. So with that, I am going to stop sharing, and I'm going to hand it over to Christina.
Yeah, thanks, Richard. Do you all have a process for taking questions? Do people usually put them in the chat and leave them to the end, or is it up to us?
A lot of times they go in chat, and then maybe if there's time at the end, people can sound off if they prefer to verbalize their questions. Yeah.
Great. Sounds good. Okay, I will share my screen. Everything's loaded. All right. So hi, everyone. Very glad to be here to speak with you today. So as was introduced, I'm Christina Koch. I'm the Research Computing Facilitation Lead for the OSG and PATH project. And I'm joined by my colleague, Tim.
I'm Tim Cartwright. I'm the OSG Campus Coordinator. We'll talk about what that means later.
So as a quick introduction, we wanted to set the stage with why we're doing this. Like, why are we here? Why the PATH project? Why the services that are offered as kind of OSG services? And this statement at the beginning is that we believe that computing should not be a barrier to research. Don't let computing be a barrier to research. And we want to be able to help researchers ask questions like, what if? Like, what if I could do this thing because I have access to computing? So there's 2 examples on this slide, one from a botany lab here at the University of Wisconsin-Madison that transformed their work by asking, what if we could measure and compute information about not just one growing Arabidopsis plant, but potentially hundreds of them? And on the right is a more recent project, a collaboration within the OS pool with, I think this was NOAA. What if we could process hundreds of thousands of sonar images and kind of test drive and try things out without having to spend a lot of money? having to spend no money in this case. And so that's why we're here, and what drives a lot of what we're doing is we want to accelerate people's research through access to computing. So what kind of computing? There's lots of computing philosophies and approaches out there. We are experts in high throughput computing. Very briefly, what that means is lots and lots and lots of small, so for some definition of small, self-contained tasks. That could be a single list of jobs where you just need to process a bunch of things at once, or it could be a larger workflow where there's some sequential pieces, but where each step might have many tasks that need to be executed to move on to the next step. So we'll have a few more examples of that later in this talk. So why HTC? So this is the kind of computing we do. This is what it is. Why use this approach? We think that high throughput computing is widely applicable to, on the research side, a large number of research domains and the kinds of computational problems that they have. And it can also be more accessible and applicable to people who are trying to provide computing services in terms of the needs that are required to support it. So that's a little bit of what we do. There'll be some more information about this as we go through the talk. And so the activities that we're going to talk about in the rest of this presentation are funded by the PATH project, an NSF grant called the Partnership to Advance Throughput Computing. And it really does represent a set of partnerships to advance high throughput computing tools and technologies, advance the research of scientists and researchers across the country, and to advance high throughput computing infrastructure through partnering with different organizations and sharing capacity. So that's the context for this presentation. And so we're going to have two major sections to this talk. I'll be speaking first about how researchers and campus staff can use the high throughput computing capacity that's provided through PATH OSG. And then we'll pivot to Tim sharing about how you here is you or your campus, how groups or institutions can partner with us and contribute to those existing services. So with that context, I'm going to dive into resources for researchers, specifically the Open Science Pool or the OS pool. So again, important takeaway message: if researchers on your campuses are limited by computing, and they can benefit from what we can provide, they can start right away. You fill out a form, you meet with us, you start running your work, and there's a test environment that you can use to try things out at any point in that process. That's the message. I'll go into a little more detail about each of these in the following slides, starting with benefiting from what we provide. So what kind of work will really take off if you use the OS pool? So the ideal high throughput computing workload, one way to think of it is as a list of jobs. And again, where a job is some unit of work, a task, a program you want to run. This quote is from our PI from a presentation he gave, I think, last week, that we can advance the science of researchers who have computational workloads that are a list of jobs. It can be that simple. And to be a little more specific, here's what that might look like. It could be, I have a bunch of images and I want to extract something from each of them, or I want to run an inference on my database of 50,000 documents, where again, that's sort of each of those is being processed separately. I want to run a simulation for each set of parameter combinations of interest. I want to compare each of these pairs of genes or genes and phenotypes. So this is just a sampling of the types of problems that can really be scaled out on the Open Science Pool. Okay, so you're a researcher at a campus, you're limited by computing, you have this kind of problem. Can you use the OS Pool? Yes. So the main requirements are that you do need to be affiliated with a US-based academic, government, nonprofit organization. But I'm guessing that's most of the people on this call, or the people you work with. And it really could be, otherwise it doesn't matter. You could be a single grad student that's just grinding through a project for their PhD. It could be a whole research group. It could be multi-institutional, like a multi-institution grant of people working together. It could be research staff, like some of you are, I'm sure, just wanting to try it out, and instructors who might want to use something like this for a class. So also really important, your institution doesn't need to be contributing to the OS Pool for you to use it. They're completely separate things, which is why there's two parts to this talk. So if you want to use it and you're affiliated with a US-based academic, government, or nonprofit organization, then you can request an account. So you fill out this form on the website. It says 5 minutes here, but I think it's even shorter. Like, it really is kind of your name, some general information about you, and then some information about your research and your computing needs. And then that form comes to us, and we do a orientation or onboarding meeting to confirm that the computational work that a researcher has, that we can support them. And if not, we'll try to direct them to different resources. But can we support you? How do you get started? Here's how the whole thing works, kind of helping people start on the right foot to get their work done. And so this ends with how you can be supported moving forward. And a lot of that support comes from our facilitation team. So here's our current team of 5 facilitators. Like many things we do, geographically distributed. And we will do this account creation and onboarding process. So you'll work with one of us to get your account and get started. And we also help support these other activities for folks who want to use OS Pool computing capacity. And so the message here is really like, you don't have to, hunker down in your office and it's just you versus the terminal, right? You can participate in our community and get help and connect with people, and it will be more fun, hopefully for you and for us, as you get started on these resources. So there's a lot of different channels or modes of connection with us listed here, including one-on-one help, asynchronous help, training, regular training opportunities. And I'll do a plug here for community events. This HTC 24 is Throughput Computing 24. There's a week-long conference in Madison in July, and it'll show up again at the end of the presentation as something you should consider as part of your summer plans. This is a great way to connect with the community as a whole, especially if you're, I think, in the role that a lot of you are in an emerging center kind of context, and you want to meet us and pick our brains, and it's a great place to do that. Okay, one final service that researchers, or again, anybody who qualifies to use the OS Pool can use to get started is this notebook interface, so what we call OS Pool notebooks. And there's 2 versions of it. If you have an OS Pool account, this will just connect to your kind of login, and you can use it to submit jobs, and the jobs will go run on the OS pool. If you don't have an account, it will create a little test environment for you to use. So this is great for trainings, for if you want to try out what job submission is like before you get an account, or you applied for an account, but you just can't wait to get started. You could use this as sort of a test space to proceed. So that's the survey of our part one, how researchers can use the OS pool, why, how to get started, what supports exist. So I'm going to do a quick overview of what the OS pool is, and then we'll transition to the other half of this talk. So I've talked a lot about the OS pool, the Open Science Pool, but what is it actually? So here's a little story that I think many of you are probably familiar with. You're at a campus, your campus researchers need computing, and so you buy some servers. Maybe you make a little cluster, maybe you make a big cluster, but you invest in some local resources to support your campus. Great. What if your researchers aren't using your cluster all the time? So there's always a little bit of extra that's maybe not being used. What if you took that extra capacity and kind of pooled it together to make its own virtual cluster, and that virtual cluster could be made accessible to other people? Don't need to be at your university, could be anywhere in the United States at an academic, nonprofit, or governmental organization. This is what the OS pool is. I mean, so that's the concept, is that individual groups can contribute to this cluster of sorts that's sort of created by pooling all their resources, and it's available to researchers. So the OS pool is kind of our main flagship service, this pool of high throughput computing capacity. We also operate what we call access points, what most of you would probably call login nodes, that are where you submit jobs to run in the OS pool. And we use htCondor as the scheduler for that. And then there's an associated network of data servers, origins, caches to deliver data across the OS pool in support of high throughput computing workloads. And Tim will touch a little bit on that as well in his section of the slides. So there's the services. To give a sense of scale, this is the last 365 days, maybe from like a month ago, should still be pretty accurate. This is the number of jobs. So again, if high throughput computing is a list of lots and lots and lots of tasks or jobs you want to run, 150 million was the last 365 days. Our PI, Maron Livni, likes calculating the hertz of jobs we run, so the rate of jobs per second. So we did the math, and this is like 4.5-ish hertz, job hertz, 4.5 jobs per second over a year. And I really like this graph on the right just because it shows usage by different, the institutions, affiliations of the researchers who are using the OS pool. And this is like a real variety, right? Top user is Wayne State. And then farther down you have, I don't know, University of Chicago. And then you also have Fermilab. So this is really something that anybody who has the need can apply, step up, and use. It's not restricted in that anyway. So with that, having covered how you can use the OS pool and what it is, I will turn it over to Tim to talk about how the OS pool is made and how campuses can participate in contributing.
All right, thank you, Christina. So if you can remember back just a couple slides when Christina had the map with the little individual clusters on it, I think it's important to realize that with a very minor exception, the OS pool consists of capacity that comes from campuses, that is contributed by campuses. So we aren't magically owners of vast amounts of computing capacity, but we are really the sort of facilitators and providers of services that let all of you and others contribute capacity and create this national cyber infrastructure. So why contribute? There we go. I think the big thing is really that a campus is interested in joining this larger ecosystem and contributing to a national scale infrastructure, beyond their own campus borders. That's a pretty powerful thing, and this is very much supported by at least one NSF program, the NSF Campus Cyber Infrastructure Program. It's usually called just CC Star, and I want to take a little digression here because we think the CC Star program is fabulous. So this is a program, it's running once or twice annually, and the NSF is giving out money for a variety of kind of different programs to build out campus infrastructure. We focus on the compute and storage ones, but there's also some networking and even planning ones. But for computer storage, you can get up to $700,000 for a local system, or 1.4 million for a regional system, and you get 2 years to do that. And at least for the compute and storage areas within the overall program, the solicitation says that you are required to share 20% of that capacity with something sort of bigger than the scope of the award itself. And in both of those areas, Path is mentioned as one option for doing this kind of sharing. So yes, NSF is putting sort of specific requirements in to do this sharing, but I think that the big picture goal here is that, very much like that first bullet on the slide, they are interested in seeing campuses extend beyond their borders and join something at the national scale. And this has worked for campuses large and small across the country, and it's a really great program. So we encourage you to think about that. The next submission deadline is mid-October, and I'll have a link to that at the end of the presentation too. So some other reasons for contributing. This is, as part of growing beyond your borders, it gives you an opportunity to sort of connect with and learn from other campuses and the kinds of ways that they approach their own local infrastructure, and also the sharing aspect of it. And a very pragmatic usage. Christina kind of alluded to this, but maybe you're not using all the capacity that you bought. You sort of bought local capacity for what you expected your peak usage might be, and that only happens some of the time. And I'm going to put power on my laptop before it dies. But you're probably not using that peak capacity all the time, and so you might as well see those machines get used, and you can do that through sharing. Okay, so decided to contribute, great. What are we trying to do? So we as the Path Project and the OSG Consortium, we have many goals in mind, but I think a few key ones. We really want the amount of effort that campus staff have to put into this process, the sharing part, to be as minimal as possible. We want to make it easy, no-brainer, just do it and go. At the same time, and this second one is really one of our very core principles and has been since the beginning of high throughput computing. We recognize and believe strongly that you retain control over your local resources. They're yours. So there's always the opportunity for you to change how the sharing works, to turn it off. And I mean, literally, you can just go cut off the sharing now if you need to for some reason. These are your resources. We really appreciate if you're willing to share any of that capacity with us. I said this before, but I think it's worth emphasizing. We also want campus staff to learn from others outside of their campus and help researchers get access to computing capacity. And we also benefit in the way that we provide our services by learning from you. So things don't always work as planned, and you can help us improve our services. And this is this feedback loop is an important part of how we work and how we continue to provide, we hope, the best possible services to the academic community. Okay, so how does this work? we have a couple ways to actually make the sharing work. I'm mostly going to focus on the first one because it is the most common. I would say 90+% of campuses are using this method. So I'm going to say we and you a lot. And by those things, I mean, we are really OSG services and you are your sort of local campus services. I'm not talking about people here. So we're going to request capacity from your system, and that's going to be in the form of job submissions to your cluster. And we're going to do this based on demand that we see in the OS pool. At some point, you decide to share some of your capacity. So we request, you say okay or no. And once you share some, then we set up the environment on each bit of shared capacity, a worker node, that we call an execution point. And that's, I'm just going to abbreviate that EP here. And then that EP phones home to the OS pool central services and says, hey, I've got some capacity here, please use me. And at that point, that little bit of shared capacity becomes part of this larger national OS pool infrastructure and is available to the researchers who are running there or want to run there. So then the OS pool workloads will run in those EPs. Option B, I'm just going to mention, is a little bit different in that you fully decide what capacity to share and when, and you do so in the form of running containers. But interestingly, the last two bullets are exactly the same. Once you fire up a container, it sets up an EP and shares that with the OS pool. Okay, so there are some requirements for making this all work. This is mostly for option A on the previous slide, so the thing where we send in capacity requests. So this kind of gets down into the nuts and bolts a little bit. We need an account on a submit node on your cluster. And furthermore, we need to be able to SSH into that account. So that means getting through your firewall, potentially. And we can work with you on lots of ways to get that done in a safe way. And again, when I say we, I'm not talking about me personally, I'm talking about computer services. So we use public-private key pairs to automate this. Unless you happen to be running htCondor as your local batch system, we will need shared user home directories between the submit and the worker nodes. I think on all non-Condor systems, this is completely common and standard, so that's usually not a problem. We will need some scratch space, preferably on each node, although we certainly work with clusters where all the scratch space is on a single shared file system, local single shared file system like BGFS. And this one's kind of interesting, the last one, because it trips some places up, but we will need outbound network connectivity from the worker nodes. So let me explain why this is the case. We assume that your worker nodes, unlike the submit node, we assume your worker nodes are fully firewalled off, natted off, whatever, from the outside world and cannot be reached with incoming network connections. Therefore, in order for any sort of services to work, we need outbound connectivity. And that's how we reach our own services. And it's also how these researcher payload jobs that eventually run there will reach out and get input files that they need or an output and things like that, or access other network services. So that's the stuff that we need from you. And we work with you through this whole process, of course. And then all the other services that are required to make this work, we host and operate. So again, we're trying to minimize the amount of effort that you have to put in. Okay, so in a picture, without getting too deeply into our jargon, this is kind of how things look. So your cluster is over there in blue on the right, and we have a bunch of services that I'm not going to detail. You might hear words like glide-in WMS and front end and factory. You will hear more about something that we call the hosted CE. So that's a service that we run and host on your behalf, and it's specific to your site. And that is the service. When I kept saying we, is actually this service that will SSH to the submit node of your cluster. And I show it very, very carefully there, threading the holes of your campus firewall to get into your cluster. And then I've shown inside your campus cluster that I've shown some orange dots, which are the capacity that you've shared with us and that we set up the EPs on, and then those report back to the OS Pool Central services. And then what I haven't shown here is that then I could show you sort of a standard picture of how htCondor works, because then we have central services for a pool, and we have capacity, and we have jobs, which I don't show here, waiting to run at access points. And then that's just a Condor cluster doing its normal Condor thing. We haven't talked much about OSDF, the Open Science Data Federation. It is also possible to contribute storage using the OSDF. The details differ a lot here, but the picture is in some ways kind of the same. So you have storage behind, we again assume a firewall or something that's blocked off from us. In the storage case, we need you to operate a host that's dual home, so it can see on the inside and can see to the outside. And that we call the origin service. You just need to run Kubernetes. We run everything from there up. And those services, the origin services, you will mount just certain file systems that you want to share to the outside world. And then the origin is responsible for actually making that visible to the outside world. And so the Data Federation is again a national scale data, not hosting because you do that, but data sharing service, including a robust caching system around the country. Okay, I just want to talk a little bit about some of the sort of processes that we use to do all this stuff. Typically, as you might imagine, right, there's planning processes, there's the actual process of getting your stuff to work with our services, and then there's kind of ongoing operations or supportive operations. Again, we try to keep your responsibilities to a minimum, but we do need a few things from you. We need to know if your stuff is changing. I can't tell you how many times we've noticed something that used to be there yesterday and isn't here today. And when I send an email, they're like, oh yeah, we're moving our cluster to a new data set. We're going to be down for a week or two. We'll let you know when it's back up. If you let us know ahead of time, that's wonderful. Once in a while, we'll have operational requests for you. If we notice something that doesn't seem to be working, we hope that you can respond in a timely manner. And for really big changes, if you're going to have a new cluster, or if you're moving your storage, or maybe you're getting a new kind of storage, underlying storage system, sometimes in those cases we'll sort of treat that as a new planning and integration process if it's significant enough. And I don't have the fancy map that Christina did, but here's just a few folks that help out with kind of on the integration side of things. So I am a campus coordinator, and so I coordinate all this stuff with you and with our team. And then here are just some of the folks that you might actually see on other calls. Okay. So wrapping up for both of us here, again, we've talked about how your research can benefit from the services that we offer, and about what that looks like and what it entails. I've tried to paint a picture of, well, Christina then kind of talked about what the OS pool is. I tried to explain a little bit about how it gets to be that. And so just a few things to wrap up. We have our desired action items for you. Whether you do them is up to you, of course. But we would really love to see a strong campus turnout at our Throughput Computing 24 conference this summer. So it's up here at the University of Wisconsin-Madison. It's the week of that second week of July. So kind of the week after the week of the 4th. There's a link, you can go check us out. But we'll have a fair amount of even campus-specific programming on at least the Tuesday and Wednesday. There's the Wednesday has lots of overlapping things going on, but there will definitely be a campus component to that. And the schedule is slowly coming together, but you can already see kind of a block schedule of how the days are arranged and what parts might be interesting to you. You can register for individual days, so you don't have to come for the whole week. You can even take a couple of days or a day and come join us. We'd really love to have you up here. As Christina said, if your researchers need computing beyond what they can access locally, please, please, please send them our way. There's the application link. There's the link for more training stuff. I think Christina had some links back in hers.
And I'll add, you don't need to have an account to participate in the training usually, because you can use like the guest notebook setup. And you don't have to be a researcher. I will say, if you are supporting researchers as IT staff, you are also welcome to get an account and attend training. Anybody that's part of that whole using computing for research enterprise is welcome to get accounts.
Yeah, good point. And then kind of from my perspective, if you have some existing capacity and you'd like to try this whole sharing thing, please work with us. It really doesn't matter if you only have a little bit of capacity that you think you might be able to share. Sometimes great things come from small starts. So we're happy to work with you. Just email us at our support link there, and you'll probably end up talking to me, and we'll see what we can do. And then if this is the right opportunity for you, very strongly recommend looking at CC Star solicitation that I've linked here. Again, there's 2 this year. The first one was in April, but the second one is coming up in mid-October, so there's still a chance to do it yet this year. And they seem to, it's a really strong program, and they tweak it each year, but it's been very consistent now for well over 10 years. I think we're into a dozen or more. So it's a great program, and please check that out. And that's all from us. I'd just like to acknowledge that the PATH project is in fact funded by the National Science Foundation. So thanks to them for making all this possible. And we'll take questions at this point.
We will
So,
also share the slides.
oh, thank you. Yeah. Well, so those slides will end up in the call doc, and we usually put them on our page on the CARC website. Tim, would you be willing to go into a little bit more detail? If I have a resource at my institution and I want to share, what are the kind of requirements that are needed of the institution, and what kind of benefits accrue?
Sure. So actually, Christina, if you don't mind sharing and going back to slide, probably 25 is the most helpful. So the requirements on your side, for the resources themselves, I didn't go into that in any detail here, just because it gets a little down into the weeds and it's a little squishy. I mean, we'll take almost anything. That's what it amounts to. On the compute side, I think in terms of ratios between the number of cores being contributed and then the memory and storage available with those cores. So a good starting point to think about is for each core or hyperthread, I'm just going to say core though, for each core, 2 gig of RAM and maybe 5 to 10 gig of disk. We can work with less than that, but that's a point where if you hit those minimums, on a typical day, a quarter to a half of all of the jobs that are waiting to run in the OS pool can fit on that kind of a capacity. Bigger is always better. We can talk about it. We can talk about different ways to kind of slice and dice capacity, but that's a good starting point. On the OSDF side, honestly, I don't think there's a minimum in terms of actual storage capacity. So for instance, if you've got a researcher with some large data sets that are public and that are of interest to others around the country, those could be shared using the OSDF and just make them available to more people sort of more easily, including with a caching infrastructure, so that you're not beating up on your local site all the time. There are probably some networking guidelines that we'd want to talk about in terms of the whole path out from that storage capacity out to your firewall and out to the internet. If you're on a dial-up modem and you want to share terabytes of data, that's just not going to work. But I think at that point that's kind of fairly obvious, but we can always work through those kinds of numbers too. And then for process wise, I think I had the slide 25, which just at least about on the compute side, kind of the other things that we need. These are the nuts and bolts of what we would work with you to actually set up the integration for compute. And likewise, there's a comparable list of requirements for sharing storage capacity with the OSDF. As for benefits, I mean, that was, I think I had some of this on slide 22. Christine, if you want to back up a little bit more. Some of them are a little bit, kind of, as our director likes to say, motherhood and apple pie. I mean, they're kind of big picture, like, we hope that campuses are motivated to think beyond their borders when it comes to research computing, because research computing is an enterprise that occurs across, you know, research efforts in the country. And so why wouldn't we all sort of, you know, treat this as something we're kind of in together and should help each other out with? Again, if you've got a CC Star Award, you need to share 20% at least. But I'll say something interesting there that I think is interesting, at least. So CC Awards typically are 2 years long, and then you keep the capacity after that. So many of the awardees that we've worked with and who are sharing with us, their awards ended a long time ago. And with very few, and I want to say that the number is 2 campuses, with very few exceptions, campuses have continued to share that capacity even after they are no longer obliged to the NSF to do so. So I think that's really says something about that campuses find this relatively easy to maintain, and they do see value in it. And then I think there's the last bullet there, which is maybe a very pragmatic thing, but if you want to be able to go to your you know, campus executives and say, look, we bought all this computing hardware that we want to make available to research computing, or for research computing, but gosh, locally we're only using 25% of it right now. That might not be a fun conversation. But if you can say, well, we're using 25% of it locally right now, and we expect that to grow over the next few years, and in the meantime, we're sharing it with this national infrastructure, and we're seeing close to 100% utilization, that's a very different kind of conversation with your campus executive team.
Thanks very much, Tim. I think Lauren's got a question in chat about.
Yeah, so Lauren asked a helpful follow-up question for my reply to, I think, Jerry's original question, which is there an option for data storage? So there is an option for data space for running jobs. And so the OS Pool access points that we operate, I think the default is you get 50 gigabytes in your home directory, and you get 500 gigabytes of space that's kind of like served or accessible via the Open Science Data Federation. We can increase that by request. You know, talk to us as usual. If you're thinking in terms of like long-term storage or hosting some kind of like big authoritative kind of reference kind of data set, that might be a slightly different conversation. Then we veer more into the territory that Tim was just describing of like, maybe that's hosted, you know, hopefully if you have a data set of that scale, I'm thinking like, you know, tens of terabytes here at least, or bigger, that you either have some kind of home for it already that we could work with you to share via the Open Science Data Federation, or we could, you know, talk about what a more formal collaboration or partnership for supporting that data would look like. But the kind of baseline, you're a researcher, you sign up for an account, you do get a certain amount of space to actually run your work and get it done. Other questions? People would like to know.
Okay, well, Christina, Tim, thanks very much for bringing your presentation. I really appreciate it. For folks on the call, if you've got ideas for other calls you'd like to see, please feel free to reach out, put stuff into the call doc, or otherwise let us know what you'd like to see for future Emerging Centers calls. We really appreciate you folks coming to present to us and sort of broaden our perspective on the community. And thanks to our track members for attending and providing questions. So thanks very much. All right, take care, everyone.
Thanks, everyone.